As we look now at temperature, temperature by definition is a measure of average kinetic energy of molecules. The equation for the average kinetic energy is 1/2 mass times velocity squared. Mass has to be in kilograms. For measuring thermometer, I really won't get into that equation. But measuring thermometer, we're talking about thermal expansion. Two center liquids that can be used or material used for thermometers have been mercury and alcohol, though a lot of the electro thermometers today have gone digital. But again, there are limitations on melting point and freezing point for that. What's important now is down to the temperature scales. The 1 Kelvin has an asterisk by it because it is an absolute scale, meaning it has no negative values to it. Celsius and Fahrenheit are both ones I give to you, and we'll do some conversions for that. Rankine, don't worry about Rankine. It's something it's something used in engineering. We can make our changes here. We talk about making changes from Celsius to Fahrenheit, and when we looked at temperature for Fahrenheit and Celsius, we saw the difference between them, freezing point and boiling point, was we see that approximately for every 1 degree Celsius change in Celsius, there's about 1.8 degrees Celsius or Fahrenheit change. And so we could change it from Celsius to Fahrenheit, just multiply by 1.8 and add 32. They've taken the 1.8 though and put it into an improper fraction and a regular fraction, so it's 9/5 or 5/9. Just understand that Celsius commonly is a smaller number, so to change from Celsius to Fahrenheit, I'm going to multiply by an improper fraction to make it a larger number. So for example, in that situation, 9/5 times degrees Celsius, if it was 30 degrees Celsius outside, I would divide that by 5, give me 6. 6 times 9 is 54, add 32, give you 86 degrees. So you'll be able to know how to do that in the test. I give you those equations. What's more important is what we'll do all the time throughout this unit, and understand first of all that as we work with gases, gases are always in the temperature for gases are always Kelvin. And the only information to know is absolute zero is 0 Kelvin. Nothing is colder than that. And Kelvin only Kelvin goes as 0. Its equivalent in Celsius would be negative 273.15. Therefore, the conversion, the change from Celsius to Kelvin, is simply adding 273.15. Remember, you're adding here, so you need to follow addition subtraction rule, which is least number of digits to the right of a decimal. And we made some conversions here, went through some practice here. First of all, I had you change from your Fahrenheit to Celsius. So first step you had to do there is that first subtract 32, divide by 9, multiply by 5, and that gave you your Celsius. To go from Celsius to Kelvin, you just add 273.15, you end up with 452. In this situation, we realize for this one down here, the second part, we realize that negative 40 degrees Celsius and negative 40 degrees Fahrenheit reach an equilibrium point, and that is the magic number. They do cross out at that low temperature. Next, we talked about the pressure. Pressure is the next key aspect. Pressure by units or by measurement is force divided by area, or F over A. We understand that your A in your denominator is going to have an inverse relationship with your pressure, and we did this through the hand versus needle in that situation. Force and pressure are going to be directly related, and we saw this with the actually there's our the area. We actually have the bed of nails. We have that example. You increase the area, you're going to actually decrease the pressure. But if force and pressure are directly related, so it's important you understand that relationship as well. Next, the units for force over area are Newton per meter squared, which is the same as the Pascal, where we use a kilopascal. So we have that's our measurement we actually use. Other ones we can use are PSI, which is pounds per square inch, ATM atmospheres, millimeters of mercury. Remember, HG is mercury, so I can have millimeters, I have centimeters, I have inches, mercury. So millibars is MB, Torr is Evangelista Torricelli, who developed the barometer and used millimeters of mercury. So millimeters of mercury and Torricelli or Torr are numerically the same. You can have inches mercury, centimeters mercury, all those. Well, let me give you some conversion factors. I do provide these conversion factors to you. They're all equivalent to 1 ATM, so they're very, very helpful as we go forward in that. So again, these conversion factors are all given to you. Very, very important to understand that. You don't have to memorize any of those. As you look at this, we just practiced some conversion factors. We've done this already in class as well. Again, I know I'm going from PSI to kilopascal, so I looked up their equivalent, and I realized that 101.3 kilopascals is the same as 14.7 PSI. So I put my 14 or kilopascals or 14.7 psi for one reason only, so my psi would cancel out. Multiply, divide. Millimeters of mercury and torr are the same thing. And then 725, well, I know for every 760 millimeters of mercury, I get 1 ATM. So 725, I don't quite have 1, so it's going to be a number less than 1. And there's my answer, 0.954. Talk about a barometer. She measures the actual atmospheric pressure, and what's unique about the barometer, again, based upon the scale that you're actually using. In this situation, the scale is in centimeters, so they would measure this as centimeters mercury. We've seen that it can be in inches. It can also be in millimeters, or ones that can actually be used. What we understand here, as the atmospheric pressure increases, as the mercury is pushed down, and then it climbs actually up the tube, and as they reach it. So we realize, well, on the news you'll see a high coming through or a low coming through. The high means it's going to be a higher barometric pressure, expect some good weather. The low means is going to be, again, the atmosphere is dropping, the atmospheric pressure is dropping, expect some not so well weather coming through. Atmospheric pressure is exerted by atmosphere due to collisions of gas particles on any surface. What holds our atmosphere intact is gravity. Understand, as you go up into the mountains, why you may take a bag of chips and as it expands, because you're going to go up the mountains, there's less atmosphere above you, therefore less particles, therefore less collisions, lower pressure. At sea level, however, when you come back down, there's more atmosphere above you, therefore more particles, therefore more collisions, therefore you have a higher pressure. At sea level, it's important to understand that we have 14.7 pounds per every square inch. We always realize the impact upon that and how strong the atmospheric pressure is. Also remember that STP stands for standard temperature and pressure. In temperature terms, it's 0 degrees Celsius or 273.15 Kelvin. In pressure terms, it's 1 ATM or its equivalent, 760 millimeters mercury.